Group. We are here to present our final year project's presentation on the topic Real-Time Health Monitoring System with Infusion Control, which is being funded by National Technology Fund Ignite. We have been working under the supervision of Dr. Aslan Ahmed, who is currently working as Assistant Professor, Department of Electrical Engineering, Sakhra University, and Engineer R.F. Hussain. The context which we will be dealing in today's presentation are the background survey of our project or our research, introduction, desired aims and objectives, comparison between some manual infusion systems and automatic infusions. Moreover, we will be also dealing with the working mechanism, methodology, design considerations, results, and in the ending part we will be dealing with the conclusion and some future works. Moreover, if we can say that if we talk about some background survey related to our health sciences, then in 2017 census, the documented the population is at around 40,87,903 persons who are currently being registered with the statistical census of Sakhar, and the number of households we can say that 2,63,042 houses are there. Moreover, which is these statistics are being provided by the Pakistan Bureau of Statistics, Government of Pakistan, and from the Health Department of Sindh. We have been received an annual reports from 2018 that we have only 107 healthcare units, means directly or indirectly we can say that these healthcare units are the hospitals, dispensaries, and the healthcare sectors, in which total of 498 doctors are registered, and we have only one medical college in the vicinity of Sakhar district. Moreover, if we talk about some background survey related to the intravenous infusion on which our project is being, or we can say that our project is related on that topic, is intravenous infusion is the controlled supply of fluid, or we can say that it is prescribed medication which is being continuously infusing into the bloodstream over the time, which is the fundamental part of every healthcare units. Moreover, the conventional type of infusing the medication, or we can say that the liquid medications, are the normal drip systems. And why we are moving towards the automated, or we can say that the controlled infusion systems, because we in some amount of in some types of diseases we need the precise and controlled infusions, because we can say that we can take the example of some electrolyte imbalance, which is the name of a common disease, which need very precise and accurate infusion of the nutrients or the medicine which is required at regular intervals. This is the reason due to which we need the controlled and precise infusions, which till now the conventional drip systems haven't been achieved by that. Moreover, some manual adjustments require someone constantly on site to keep the infusion flow rate constant and to prevent situations of over and under infusions. For cases that require programmed medicine or nutrition volume, infusion pumps provide constant flow rates. Such equipments, however, is very expensive, as well as they become uncomfortable for patients, which involve involuntary movements. Moreover, when we visited Civil Hospital Sakhar, we saw that there is a much need of the well-equipped equipments which we can provide, with which we can provide the instant medications, as well as the proper monitoring of the patient's health for the concerned doctor as well as the relatives. In addition, if we talk about some different scenarios, then we have seen in Sakhar district there is only one public sector hospital named as NICVD, who has the well-equipped machinery, or we can say that the well-equipped equipments for which they can, we are having some the examples like syringe pumps, health monitors, and etc. And this is the only one hospital which is being situated or in the vicinity of Sakhar, which is in the very less amount. Moreover, the all other hospitals have deficiency of the well-maintained setup for the local citizens also. If we talk about the introduction, then we have made an attempt to introduce an automatic, feasible, accurate, and properly functioning device which is necessary to impose a healthful effect in needful manner. Moreover, if we talk about the syringe pumps, which is the main topic of our presentation, are used to modulate a small amount of liquid flows in a programmable, some customizable way, but in a very cost-effective fashion, which is the main point of this presentation. Moreover, as the monitoring and infusion control over the hospitals is a very crucial but important task nowadays, and the most importantly, in the vicinity of Sakhar, we are at very back in this field. If we talk about some research, or we can say that there is some study related to our project, that the data analysis and research, there are two types of infusions. Number one is manual type, number two is computerized or processing based or programmable based. And the deficiencies in the conventional systems are, we can say that the response of that conventional systems is a bit slower than the nowadays requirements are there. There are some, how we can say that they are also inaccurate, and most importantly, they require continuous monitoring setup over the system, or we can say that the setup in which we will be dealing. So, in this presentation, we will be dealing with our aims and objectives, like we have to provide a smart health system for the private as well as some public sector hospitals. A smart health system which can provide a user-friendly interface for continuous monitoring of patients. Thirdly, on the basis of patients' monitoring system, decision will be made for the infusion of medicine. Either it has to be infused at high volume, flow rate, and some vice versa. Moreover, in case of a critical or severe conditions, the generation of an alarm for the doctor is also an objective of a task. Now, if we talk about some comparison about the manual and automatic infusions, like in manual infusion, we require some administrative staff. This is a very hectic job. Thirdly, it does not hold any precautionary alarms for the severe conditions. Fourthly, the flow of infusion is irregular on the regular basis. Fifth, on the part of it, the flow cannot be properly estimated or calculated if we require some calculated and estimated infused volume. And finally, these systems are not very accurate in the terms of the constant flow rates. Now, if we talk about some automatic or computerized infusion systems, then they have the features of they are very larger, they hold a very larger capacity and wide range of flow rates. Secondly, they are feasible to opt in the normal situations. Moreover, they are the drug saving equipments. And fourthly, infusion warning alerts are there, and we have also having the features of cautions or alarming situation in the alarming situation. And finally, they are very cheaper as compared to the conventional drip system on the whole. So this is basically the working mechanism of our project, or we can say that a prototype which we have designed for this cast. We will be dealing, or we can say that we will be holding some graphical user interface, some power supplies, some controller based boards, some motor drivers, some motors, and finally we will be dealing with the most precious part of our project, which is basically the pump, or we can say that the syringe pump. So the next part will be defined by my groupmate with the methodology part.
So the method we convey the mechanism of our project is as software is apart from hardware and software. In hardware, and we use the two methods. For first was SolidWorks, and second is InKSpace, in which we have designed the outer part and the case of the our project's body, and the software based system is involved around the Arduino based software and MATLAB. In Arduino, we program the overall case of our project, and MATLAB, in MATLAB we have a post process of our project. Next. So these are the outer SolidWorks parts we have designed at the SolidWorks. These first one is motor holder, second one is the syringe clipper, which is given here. This one, and the third one is the pusher, which pushes the syringe to infuse a fixed amount of liquid, and third one is the holder for the syringe. So figure 1 number 5 shows that the overall case of our infusion system. So second figure shows the 3D part infusion acrylic, in which we have designed in InKSpace. And next, So this is the overall look of our 3D model, which is given is here. Next, this is the finalized product in which we have assembled all the case. First infusion syringe system, and then assemble the overall part. So the methodology to assign to working principle for this project is as given. First of all, the first page shows the menu, and the second one is the manual control. It has two options. First one is the manual control, and second one is the automatic infusion. In first control, we can move manually in gas. As we can see here, it has two options. First one is the manual movement, in which we have the 4 or 6 options. First one shows the motor 1A configuration, in which if we click the button forward, so it will move infusion like this. This work at the. So I have shown the first infusion of motor A, in which we infuse the liquid at the rate of 200 step per revolution at 2.5 ml. Now we can move that the second syringe infusion, like by clicking the forward button. If we click the backward button, it will diffuse the liquid. So this is the manual movement, and the second part of our project is the automatic infusion. It contains sensor-based infusion and the user-defined infusion. In sensor-based infusion, we use the pulse sensor device, which can detect the infusion through the pulse rate. And second is the user-defined infusion. In user-defined, we have two other options for fixed rate and the required rate. In fixed rate, we have the 1 to 12 fixed volume to infuse at the rate of various step per revolution. Like first, we have to infuse at 70 RPMs, SPRs, step per revolution, and the overall, as we increase the step per flow, we increase the step per revolution. So in fixed that's all for the fixed volume infusion. And the second part of the this project is the required volume infusion, in which we have two options, like single syringe infusion or dual, because we have the dual system infusion system. For first, we have if we use only one syringe system, so we click at the single syringe system. And second, for if we use the both for mixing or combine the solution, we use the both syringe system. So let's see how that work at automatic infusion. So I click at the automatic infusion. It has two options, like user defined and the sensor based. In user defined, there are two other options, like fixed rate volume infusion and the required rate volume infusion. Fixed volume infusion has two options, like motor 1 infusion and this motor 2 infusion, in which if we infuse the given rate first infusion is done. Now we can move the second infusion. So I have selected the 5 volume at the rate to infuse volume. So the fixed second syringe pump is moving. Now back, we have another part, that is required volume. It has two options. For first one is single infusion system, if we use the single syringe pump, and second one is the dual infusion pump, which would work for both syringe pumps. I have selected the single. So in single infusion pump we have two options. First one is the volume, which required fixed volume per ml. So we select that and input the volume for infusion. Like I will give the 10 infusion volume, and the flow rate for that is 2. So the system will infuse at the 10. In manual movement, we have these 4 buttons for the infusion and forward moving and backward moving. For syringe A, upper and the bottom button work as the upper button work as the forward movement, and the lower button is work as a backward movement. And like these left and right buttons work for the syringe B. The left one used as the forward infusion, and the right one is used as the backward infusion. So currently my system is on, so I am at the manual movement infusion. I click the upper button, so the system is working. So syringe 1 is infused like this, and if I click the bottom button, so the system is diffusing the liquid like the same. The second syringe is infusing and then diffusing. Now we are seeing the sensor based infusion. For that we have placed the sensor at the index finger and open the menu. So it takes some time to set the pulse. So currently my system is working. So that's my system is working. So the methodology we use are the step per revolution, which is for the manual infusion, are the 200 SPR. That's constant for the my manual infusion, which require that's for the changing the syringe in case of infused volume. And the second is the automatic user defined, which I have already seen in my project that works for that. So these are the manual infusion interface I have designed for my project. First was my home screen was has two menus like manual infusion and automatic infusion. As the manual infusion has these 6 buttons which contain forward, backward, and the stop buttons. And third screen is for the automatic infusion that contain 2 buttons, user defined and the sensor based. User defined contains the 2 infusion buttons for fixed rate and the required volume. And fixed rate we have the 1 to 12 volume can we infuse. And required we have 2 options for single syringe system or the dual syringe system. For that we have to set the volume and the flow rate for the infusion. For single we have for single and dual both we have to set the both volume. For first how much volume we have to infuse and what rate we want to infuse the volume. And the sensor base, it detect the pulse, and on the basis of the pulse rate it infuse the volume. It contain the threshold for the pulse rate is set at 60 to 100. If the pulse rate is greater than 100 or less than 60, the system will infuse the volume to the patient. So this is the our project video.
Now let me take my position back from a group mate, and I want to add something in the current working system which we have been designing since the last year. We can say that we have been designed till now. Is that whenever we put the power onto our system, then we are having basically the two options like manual infusion and secondly the automatic infusion. In manual infusion, we are been seeing the two options more, like we are having the both pumping actions like pump A and pump B for the forward, backward and stop actions. Moreover, afterwards, I want to add something in the in this part, that in the required volume infusion we are having the two features in our syringe pump, or we can say that the our embedded system. Number one is that we are having the use of single volume infusion pump, and secondly the dual volume infusion pump. These both conditions can be used in as per the need of a patient, or we can say that the scenario. Moreover, if we talk about the sensor based infusion, then we have used the sensor pulse sensor model number AD8232, for which we have been for which we are monitoring the pulse rate of a patient, or we can say that that person who is at completely bed rest. And we have set two thresholds, which is basically the lower than 60 beats per minute and the greater than 100 beat per minute, because as per the doctors of the current scenario, we can say that as per our background study, we have seen that the normal beats of a patient is at in between, we can say that the 60 to 100, means the normal beats of a normal person is at around 60 to 100. Then in between these ratios there will be no any infusion. If the beat level increases from 100 or it become the low from the 60, then a doctor can prescribe to us, or we can say that the user of this device, for which and at which amount the liquid medicine should be infused. At the moment we have set the 1 ml per unit time for which the medicine has been infused in the body of a patient for the greater than 100 and the less than 60. Moreover, by taking towards our presentation to the concluding part, that by doing this whole experiment till a very long time, we have seen this project and we have learned the importance of doing some different materialistic things and their specific properties. We have understood the importance of planning, distribution of work among our team members, we can say that Devdul Qayyum and myself, and it developed some mutual understanding between us also. Moreover, in this project we illustrated that there are some major problems with the conventional intravenous infusion systems, as well as some conventional methods for which the medicine is being infused in the patient. Or our system was proposed to reduce and solve a problem which is basically a huge problem, continuously saying that the doctor to patient ratio. Moreover, if we talk about the feature of the usability, the patient safety with the factor of comfortability. Secondly, the design system should be connected to the upcoming patient data management systems, so that these systems can exchange the information virtually. Moreover, the real-time health monitoring system with infusion control should be able to overrule all features of current infusion pumps like alarms, display messages and administrative rates. Thirdly, in order to be able to fully control the pumps, collaboration with infusion pump manufacturers like Oscilla, Chemex and so on, as it is important to know how accurate syringe pumps and volumetric pumps are at high and low administrative rates. The intrinsic variation of the infusion pumps need to be tested, which is the most important part of this health care sector. Thus, we have to contact also to the officials of Health Department of Pakistan as well as to our province particularly to optimize their services to assess whether or not our system complies with the current regulations or not. I thank you all on the behalf of my groupmate Abdul Qayyum and myself. Thank you so much.